Okay, my name is Philip Melo, and today I would like to share with you the online platform that appears to be quite efficient for training of public health informatics and technology to across various disciplines, across different participants, students with different backgrounds, and so forth. Let me just share with you my screen, and I will just discuss with you how we can move forward with. Uh, okay, so this is, I will share my screen. Okay. Yes, and what we see here is the platform. And we start with fundamentals of public health informatics and technology. And fundamentals of public health informatics and technology, we teach sort of boot camps. It's 1 month training and a capstone project. So we train a variety of things, including data sources, as you see here, then application, various topics like syndromic surveillance, introduction to statistics, health disparities. Then we have here global public health informatics efforts. Then we have security. So we just teach fundamentals and a capstone, as you know, of course, that the fundamentals of public health informatics and technology is basically includes a very important topic, which is called visualization. And we do teach visualization with Tableau Prep, Tableau Desk, or Power BI. Same thing, there is no difference. So let us just show you what we teach. So we go to this Tableau. And we, from day one, we teach students to work with real data. This is very, very important because we found out that sometimes students, they are afraid of working with large data sets like 10,000, 100,000. And so that is a very good exercise for them. So they're not going to worry about the size of the data set. So because it is easily can be worked out. So let us show you this data set we have. This is from Texas respiratory diseases. We have here about 30,000 patients. And to the right, we have various features. On Tableau, it's better to see this one. We just punch on this button, and we can see easily all these features. And to the right, we can work out various activities, for instance, descriptive statistics and other things. But I will show you how to visualize the data. But before going to visualize, we also use Tableau Prep, which is a very good instrument, very good tool for data wrangling. So we just clean up the data sets. And after that, we use we use Tableau Desk, and that one I'll show you. For instance, we take, let me see, we take, for example, age groups here, and you can see various age group, for example, 65 to 69, and we are interested in loss. Loss, it is length of stay in a hospital. So how many days that patients in total, patients stayed in a hospital. So we need LOS, we can put here. Okay, we can even change this if you want, like this. Okay, we can do a variety of things. And here is, we have here the, on the y-axis, we have age groups, and we have total loss of state. We see here that at this older age group, after let's say 60, we have maximum data the peaks of cumulative total days they spent in the hospital. Now we can take, for example, the severity. We take another one, severity score. It is severity of their disease, and we can put here, let's say, and we can look at it better to see that various severity score. We have 4 of them, 1, 2, 3, and we can see 4, and we can see how they distributed over the age groups. So that is how the Tableau works. Very good for visualization. And then we also teach students in bootcamp how to write reports using visualization and the data cleaning. So now what I would like to show you is how to use, for example, we can use EHR. And this EHR is not a conventional EHR because we installed some functionalities that very valuable, very much in use for students, for working professionals, for participants with experience already working in healthcare and public health. And we just, I will just enter. And our students learn how to put the data for patients, and they invent these patients with different diseases history, with different vitals. So if they come, the patient goes for the lab or to the healthcare provider, we have to put new task, and we have to put all this kind of data. We can hear data here is, for example, let us put patient. Just a second. We have to do search on patient search. Let's put here from A. We start. Okay, let's say Liza Andrews. So as you see here, we have this all kind of visits. We have here allergies, and this what also students learn because they can put various allergies, and imagine that a doctor prescribes some medication, and if this medication doesn't match the various allergies, can be detrimental. It doesn't go together with allergies. So this decision support system says that please take it over and think it over and please prescribe another medication. So this gives you advice. So we cannot order the doctor to do what to do, but we can. This says that this medication doesn't it doesn't match with the patient's allergies, for example. Okay, then we can have here also the images, various images. Let's see here, and for example, this one, and for images we have here a very powerful method which is called CNN. It is convolutional neural network. Together with other algorithms such as deep learning, we can have much better resolution. And actually, this we received from a doctor, from radiologist, and we can see here that they are interested in these areas, which is quite blurred, not so good. You can see not in good details, but here we have very clear images with much more detail. So I'm not a doctor, I'm not a radiologist, but I know that the doctor was quite happy with these results, and they send us more results to use this new algorithm. Regarding labs, for instance, let us see a lab. Here we have EKG, and we know that EKG is a very not so straightforward measuring, because first it measures just what's going on now. So it doesn't show any predictions, or it doesn't show how this disease can progress. Plus, can be noise here. We have different artifacts. For example, when they place electrodes not correct way. We have various things that affect the accuracy of the diagnosis of heart and cardiovascular diseases. So what we do here, we know that the EKG represents the one-dimensional time series, and one-dimensional time series specifically difficult to work with. We work much better in data science with two-dimensional maps. And to do that, we can use, for instance, wavelet. And we can see here that the heart here is a normal, but if you have slight, subtle, in some way, abnormalities, then you will have on the two-dimensional map much more information, much more resolution than you have just in analyzing all these wiggles in EKG time series. So it's very sensitive now map, which is also can be used for analyzing EKG. Then we can have here various results of, let's say, blood test. And also we are working now on the installing a quite advanced decision support system that will advise the doctor about various diagnosis, progression of the disease, and so forth. So this will be very, very useful for electronic health records in general. So installing a decision support system is the next step to make electronic health records very valuable, because they were introduced in 2009, as you know, from the government decree high-tech. And now with the installation of a decision support system, these electronic health records will become vital for patients' diagnosis. Now, I would like to show something more, and this one is training for working professionals. So the training for working professionals is quite different from just training of beginners, like boot camp, for example. We use training for working professionals for 4 to 6 months, and they learn programming, let's say R, Python, SQL. They learn various things, and what is we found out very interesting, that many working professionals who work already in various public health agencies, hospitals, and so forth, they're interested how to move data from one place to another. You know that pandemic COVID-19 strongly demonstrated that we were quite behind of things, and we could not send data with required velocity, or receive the data and send the data. So this was a big problem. And the ONC, Office of the National Coordinator, they issued a decree, which is it's called Final Rule. I just remember it. It is 170.315. This encourages the use of FHIR. FHIR, it is a protocol. It's called Fast Health Interoperability Resources, and with the use of API, it is application programming interfaces. So what I would like to show you now, that this gives this ONC decree, it is just revolutionized the whole public health and public health informatics and technology, because let's say 4 years ago, I was working on the data interoperability, And I'm not the worst programmer. I program quite, maybe I would say professionally. And it took me 6 or even 1 week to program ETL. ETL, it is a software. It is extract, transform, and load. The whole thing, it took me 1 week to write a program with the FHIR server using the application programming interface. We can do it maybe in a minute, maybe it's in a second. We will see now. So let us see now what we can do. So first of all, I would like to, this is FHIR server. We built it for students to train them, and working professionals specifically are very much interested to learn how to use FHIR server. And we have this general algorithm that can be used to send any kind of data from one place to another, even for clouds to clouds, from different repositories in different formats and so forth. We send it to the target repository where we want to store the data. So let us see now. So first of all, I have to punch to the FHIR server. Okay, and there is a mistake. The site can be reached, and when this mistake comes in, I am sure that students who worked on that before, they did not load in Docker containers. That the only thing what they have to do is to load all containers, and then it will work very fast. Let's see. First of all, we need to load containers. This was not loaded. This was not loaded. Now all containers in Docker are loaded, and then we can use this to move data. Absolutely. So when we loaded this data, okay, let's do this again. Okay, FHIR server. Yes. Okay, now it will work. Yes. So it takes a couple of seconds, and we have the result in clouds. So now I will show you what we had before. So we moved this, we moved data from original repository. Okay, so this we use this application programming interfaces, bring it to the MongoDB. MongoDB is in clouds. Okay, and we spent a couple of seconds. Let me see if we did correct job. So what we have now in MongoDB, it is in clouds. We received the data, and here is the in FHIR format in resources. The resource is called patient, yeah, and let us see now. So we have it is male, a birthday. We have here name. Let's see now name. And one name is Chalmers. Okay. Then it is given name Jim, and another is Windsor. So we will check it now if these names appeared from the data we took from initial repository. Let's do that. And we have Chalmers, Jim, and Windsor. So this is exactly what it is. So we took the data from initial repository and brought it to Mongo, to clouds, and we spent a few seconds instead of days or weeks or whatever. So this is a revolution in public health informatics and public health. Very, very important. What we what we have now, this tool, and this tool, as I said, we can use for any kind of data, and so be sure that just in the Docker you have all containers loaded, so you can take this Docker and see if all containers are loaded, because if you don't load it, this program you cannot run. So it is very simple and very universal, which is very, very good. And what is remarkable that students learn it in 1 month, 2 months. They are professionals to move data from one place to another within seconds. Okay, so this is very, very encouraging. Now, in advanced training in FHIT, we use we teach students to use machine learning. It is supervised, non-supervised data mining. We use classification, regression. But what is also important that this platform teaches students how to work with big data. And the big data is not only a large data set, but the data come in time. So we can start with a small, and then it goes faster and faster, it grows and so forth, grows. And unfortunately, that all algorithms do not work for conventional algorithms that we use for static databases. They don't work with big data analytics. And this platform, so this is after a few years, this code has become very, very short, but we just need to use different libraries here. And then we can run it. Okay, and this is a big data. After some time, it gives this plot of this data. There is lots of data here. Now, let us see now what we have here. This one, let me see here. We have a heat map. We teach students what does it mean heat map. Heat map is we have patients and we have temperature. So it is environmental effects on various patients in a hospital. And heat map also shows how many patients were affected, because this is a dark red, so we have many patients were affected, and this is health risk. So health risk here about 9. We have here with even 11. So this is so the patients with 11, they are affected by temperatures starting from 87.5 to 91.5, but the majority of patients who were affected with these high temperatures are here, which correspond to, let's say, about 93 degrees. Okay, and that was this name is a heat map. So this is quite important when you work with big data. And now also we teach students how to use multi-source streaming, because in multi-source streaming, we do not work with conventional processing, but we build pipelines. And the students learn how to build pipelines. As I said, in about 1 month and a half or 2 months, they are quite fluent, and they build pipelines to process data, not in batches, not in just in chunks of data, but the whole data in time. And for instance, I'll show you now how we can process data in, it's also big data, how this, for example, for instance, temperature affect the health risk in counties in the states. And we can see this is a code also with various libraries. Okay, so this is actually, it's a very large script code, but when we put many elements in libraries, it becomes very concise, and we can run it. Let's say we can put here 10 at the beginning. We'll have 10 plots. So it pipelines produces 10 plots. let's say, okay, 1, 2, 3, 4, more data, and finally we have this one. Okay, so it will give us constantly plotting. So we just used here for demonstration 10. We can put now 20, it will be goes 20, 40, 60, and so forth when we have many data here. All right, so let me finish today because I gave you lots of, I think, information. We have various public health data sets, so students do not need to go and explore various the websites to find, like Kaggle, for example, to find various data sets, because here we have data sets here, many data sets. Let me just see. Okay. So this is an example of typical public health data sets. Okay, so we have here also other data sets. So students use these data sets, and they don't need to go and shop for data sets around. So this is a very concise platform that gives you all information with all algorithms and so forth. What we have here, I'll show you. So we have Python codes and algorithms. So we have many algorithms here, data with conventional data sets, with big data sets. We use here algorithm for classification, regression, the decision support system, predictive analytics. So we have lots of things, and students who graduate our this training and they go to work, they still use this platform because this platform is quite generalized and they can use various software system and to use them in this data in work in their employment when they are employed, and they apply these algorithms and knowledge for their real situation they encounter in their workplaces. Then we have here midterm and final exams, and that is how it works. So this platform has become quite, I would say that quite popular, because with this platform we can train a large number of students, and we will continue this in the years to come. And we have just, I think this year we have already 137, 139 students trained, and we will do the same thing next year. All right, thank you for your attention, and bye-bye.